So if you don't have a graphing calculator on you, how are you going to figure out what the graph looks like? Well, you're going to make a little line graph. And what numbers are you going to put on your line graph? Well, you're going to put the numbers that make this 0. What numbers make this 0? Well, a -9, a -1, and a +7, which are these. So I'm going to put a -9, a -1, and a +7 down on my line graph. Okay? Now, which one will cause it to be positive? To figure this out, we go in between these numbers. Okay? So what's in between -9 and -1?
-5.
Yeah, let's go with like a -5 here. Let me go like this. Go -5. Ooh, that's a fat marker. All right. So we put a -5 in here. A -5 will make this positive, this negative, and this negative. What's a positive times a negative times a negative? Positive times a negative times a negative. Positive, because there's an even number of negative signs. So we'll be positive at that part of the graph. If we go in between here, there's a 0 in between there, right? So it makes positive, positive, negative, which is a negative. If we go like an 8 here, it'll make it positive, 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 which is a positive. If we put in a -10, it'll be negative, 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 which will be a negative. So what happens is the graph kind of goes like this, goes like this, and goes like this. Now, ooh. How far down and up it goes, we really don't care. We're just looking for where is it positive, where is it negative. Well, it's positive here. Whoop, I hit the wrong points here. Okay. I should have gone like this. Boom, boom, boom. Like that. All right. So where is it positive? Well, it's positive in between -9 and -1. And also after 7, which is this choice.
Like, how did you find the positives though?
Because I put in a number in between here. I tested it in here and figured out if the answer was positive or negative. Okay, we'll do that on the next one here. Okay, where is it negative? Well, it's negative over here and in between here. Well, over here and in between here is x is less than -9 or in between -1 and 7. Okay, so let's do it again. Another graph. Whoops. Another graph. Boom, boom, boom. All right, so our roots here are -7, -5, and a +1. Correct? Okay. So, what's a number less than -7? Less than -7. -8. So if we put a -8 in here, it makes this negative, and this negative. A negative times a negative is a positive. A negative squared is a positive. So we get a positive over here. Okay? Because we got a negative times a negative times a negative squared. So a positive times a positive is a positive. In between these two is -6. That makes this negative, or this positive. -6 plus 7 is a positive number. This negative and this negative. A positive times a negative is a negative. A negative squared is a positive. So it's negative here. Then we try 0, because 0 is in between -5 and 1. This is positive, and this squared makes this positive. Okay, what are you noticing each time here? The signs are alternating. Yes, the signs are alternating. So if we go with a 2, it should be negative, right? Well, if we go with 2, we get 9, 7, and 1, which is positive, 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 positive. Oh no, it doesn't alternate there. What happens? Well, what's happening here is it's positive, then it's negative, then it's positive, and then at 1, it bounces. Remember earlier this chapter we talked about it bouncing? When it's a double root, it bounces. When it's an even power root, it doesn't cross, it bounces there. Okay? It crosses when it's an odd powered root, and an even powered root, it bounces. Okay. So, where are the zeros? Well, -5, -7, and 1. Where is it positive at? Well, it's positive less than 7, in between -5 and 1, and then after 1. And where is it negative? Well, it's just negative in one little spot between -7 and -5. Okay? Sine functions. All right. What happens here? Well, let's make our line graph. We got a -5 and a +8. All right. So, what number is in between -5 and +8? The easiest number to work with.
0.
0. So if I put in a 0 here, I get a positive times a negative squared, which is a positive. So that's positive here. After 8, so at like 9, it's going to be positive. And then below here, it's going to be negative. Because the fifth power, or -5, is to the first power, and 8 is to the second power, so it should cross at -5 and bounce at 8. All right, so from -infinity to -5, what's happening? Is it positive or negative? It's negative. Then from -5 to +8, what is it? Positive. And then from 8 to infinity, what is it? Positive again. Okay. So what is the solution set? Well, the solution set in interval notation is where, because they're wondering, where is it greater than 0? Where is it positive? Well, it's from -5 to 8 in union with 8 to infinity. Okay, this one's just like the last one, where our numbers are -8 and a +6. So we guess 0. Put in a 0, it's 0 squared, or 0 plus 8 squared, which is positive, times a negative is a negative. So it's going to be negative here at 0. At -9, it makes it a negative squared, which is positive, times a negative, which is a negative. And after here is like 7. Positive, positive makes a positive. So what's happening is it's negative. It bounces at -8. Then it crosses at 6. Because there's a sign change. Where there's a sign change, it crosses. Where the signs don't change, it bounces. So it's wondering, where are the numbers less than 0? Where are they negative? Well, it's from -infinity till where? -8 in union from -8 to 6. Because at 8, it's 0. So you can't say it's negative there. So that's why we have the union there. Okay. For this one, this would be x plus 4 times x minus 4 times x plus or minus 6. So then you do the whole sine chart there and then figure it out. Where is it less than 0? Where is it negative? For this one, you have to factor. You have to, oh, can you factor it? No, I don't think I can factor it. So if I can't factor it, what do I do?
Graph it.
No. No. It's a cubic. Can't do the quadratic equation. It has to be quadratic to do the quadratic equation. I think I'll have to do synthetic division. We try a 1, 1, 1, 1, negative 8, negative 8, 12, 12, 0. So now it's x squared minus 8x plus 12, which is x minus 4. No, it's x minus 6, x minus 2, isn't it? And then up here with a 1 being there, it's x minus 1. So our points that we're graphing are 1, 2, and 6. So if we put in a 0 here, we get negative 12, so it's negative here. And then in between each one, the signs should change, right? Because there's no double roots, there's no second power roots, so it should change. So it should go like this, this, and this. They're wondering, where is it less than 0? Where is it negative? Negative infinity to 1, and then from 2 to 6. Okay. Number 7 is an interesting one. What numbers would cause this to be 0? There's 2 different numbers that would cause that to be 0. What are they? 0 and negative 12. Okay? So, 0 and negative 12 cause this to be 0. What would make this undefined if x was what? Well, what can't square roots be? Negative. So if x is less than negative 12, if it's negative 13, then we get an imaginary number there, so that would cause it to be undefined. Okay? Whoops. Okay, so now we want to see what makes this positive, what makes this negative. All right. So, where are our numbers? Well, we're at negative 12 and 0. So then we're going to try somewhere in between here, like negative 6. If we stick a negative 6 into this function, it's negative 6 times the square root of 6. Well, the square root of 6 is going to be positive. Negative 6 is negative. A positive times a negative is a negative. So it's going to be negative right there. So I'm guessing it'll be positive after 0, but let's check. Let's check a 4 in here. A 4 makes it positive there. Square root of 16, which is positive there. Positive times positive is a positive. What happens at negative 13? It's undefined, so we don't even check there. So we're negative. So it's undefined, and it's negative. And then here, it goes positive. Now, is it a straight line? No. But it starts right here. So it's negative from negative 12 to 0, and positive there on after. So where is it positive? From 0 on after. Where is it negative? Well, there are no infinities involved. It's just negative 12 to 0. Because after negative 12, there is no such answer. Okay, last one here. X plus 1 over x plus 2, x minus 2. So our sign chart will involve all these numbers. a negative 2. Oh, that's an x minus 1 on top. A 1 on the top and a 2. Okay, so we got to check. So let's throw in a negative 3 right away. We throw in a negative 3, the top will be negative. The bottom will be a negative times a negative, which is a positive. A negative over a positive is a negative. So going with what we've gone with so far, it should change here at negative 2. So let's see. Well, in between negative 2 and 1 is a 0. So it makes it negative on top, a positive times a negative on the bottom. Positive times negative is negative. Negative over negative is a positive. So we're negative here, positive here. In between these two is 1.5. 1.5 makes this positive up here, makes this positive here, and negative here. A positive over a negative is a negative. And after 2 is like 4, positive, 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 which is a positive. So the graph goes like this. It's negative, negative again, and up. So it's wondering, where is it negative? Well, it's negative from negative infinity up to negative 2. Then it's positive from negative 2 to 1. And then it's negative again from 1 to 2. And that's positive there on after. So that goes in there. So you got 8 problems dealing with sine graphs. Okay? Just figuring out, where is it positive, where is it negative. Don't use your graphing calculator, use your brains. Okay? Use your brains today. No, it works just fine with that. But I want you to use your brains. Because this is a learning experience, Jackson. You grow your brain. And you are not dumb, Jackson.
Bro, I'm John, bro.
Yeah, and your brother Jackson isn't dumb either. So, and John, you aren't dumb. I'm the only dumb one in this room. Hey, that's the quote of the day, right?
No, there's already one up there. It's not very good.